All right, balancing chemical reactions, or I should say equations. You know what? The best thing about this is you don't need your periodic table, and it's kind of fun. This is the Samsonic approach. What you want to do is you have to remember that the total number of each atom on this side has to equal the total number of atoms of the same kind on the other side. Now the best way to achieve this is by scanning for the largest subscript. There it is. I've got a 4 here. So start off trying to balance the thing with the largest subscript. That's usually the best way to do it. So over here I have 4 hydrogens, and over here I have only 2. And I need to fix that. Now I can't change what H2 is. I can't change the subscript. I can change how many I have. We call this the coefficient. And you can think of it as how many moles of it do I have. So if I don't write anything, I have 1. So let's just get her done. Alright, so the trick is I want to balance these 4 over here. I'm going to write a 2 here. So the way you think of that now is I have 2 sets of this. So that really means 2 times 2 equals 4 hydrogens. And over here I have 4 hydrogens, so those are balanced. Now, without a subscript, that means I have 1 carbon, I have 1 carbon. Hey, I am done. Let's try the next one. Now this next one, I'm going to scan for the largest subscript. There it is, a 3. Now I'm going to come over here, since that's an odd number. There's something about odds I want to check on. I come over here and I see an even number. And I call this an odd-even problem. So here's my approach to fixing an odd-even problem. Step 1, make the odd one even by giving it a coefficient of 2. So now if I have 2 moles of Fe2O3, what that really gives me is 2 times 3, that's 6 moles of oxygen. So when I come over here, I have to make this equal 6. So what I ask myself is, what times 2 equals 6? And the answer, of course, is 3 times 2 equals 6. So now 3 times 2 is the same as 2 times 3. We're good. Now let's look at the ions. 2 times 2 is 4. And over here, I have a subscript of 1, so I have to multiply this one by 4. Done. Try the next one. Scan for the largest subscript. By the way, don't look inside the parentheses. Look outside them. I have 2 nitrates here. So I come over here and I put a 2. I've therefore balanced the nitrates. But in doing so, I might have 2 nitrates now, but I also have 2 silvers. So I have to come over here and fix this. So I put a 2 here. That gives me 2 silvers there. Now I have 1 zinc here, and I have 1 zinc here. Hey, we're done. Try the next one. I'm going to look for the largest subscript. It's right there. It's a 3. That's an odd number. I come over here. Hey, you know what? That's a 1. That's an odd number too. So it's not an odd-even problem. I can simply multiply this by 3. Now what that means is I have 3 Cls and 3 Cls, but I also have 3 Ks now. So I have to come over here and put a 3. Now let's see how the aluminum is doing. I've got 1 aluminum here, not 3, just 1. And I got 1 aluminum here. Done. Try the next one here. Largest subscript is right here. I have 2 nitrates. Over here I have 1 nitrate. So I'm going to put a 2 here. In doing so, that gives me 2 Ks now. And over here I only have 1, so I have to put a 2. So now I have 2 Ks, which balance 2 Ks. I have 2 nitrates, which balances 2 nitrates. But I also have 2 iodines. Now the interesting thing was I wasn't trying to fix the iodine, but I come over here and look. I need to have 2 iodines. So the iodine was balanced by accident by putting this 2 here. Now Pb I only have 1 of. Don't kid yourself, it's not 2, it's just 1. And over here I have 1. We're done. Starting to get the hang of it? Let's try the next one. Look for the largest subscript. It's a 3. Ooh, might be an odd-even problem, but no, actually it's not. So that's not a 2. So I can say, well, I'm going to balance the oxygens by putting a 3 here. As soon as I put that 3 here, I have 3 calciums. I have to come over here and make sure I have 3 calciums here. But we're not done because we've got to make sure everybody's balanced. I have 2 irons here, and I don't here, so I've got to put a 2 in front of here. Now those are all balanced. Keep going. Man, we're doing great. Okay, largest subscript. I have a 3. Over here I have a 2. Whoop, whoop, whoop. Odd-even problem. Odd-even problem. When you have an odd-even problem, start off by making the odd one even. And when I do that, that gives me 2 times 3, 6 bromines. So I ask myself, what times 2 is going to give me 6? And the answer is 3. As soon as I put that 3 there, though, I have 3 ZNs. So I have to come over here and put a 3 here. Now I want to check on how my aluminums are doing. I've got 1 of them here, but over here I have 2 times 1, I have 2. So therefore, I've got to put a 2 here. Try our next one. Scan for largest subscript. Well, I could start here, or I could start here. You know what? I'm going to start here because that's odd and that's even. Now this may not work out. I don't know. I haven't done this one in a while, but let's just try this one. I'm going to make the odd one even. I'm going to put a 2 here. That gives me 6F, so I'm going to put, a 3 here because 3 times 2 is 6. Now that gives me 3 ZNs. So I need to come over here and put a 3 to balance off my ZNs. Then that gives me 3 carbonates. And look, I needed 3 carbonates. I got 3 carbonates, 3 carbonates. I got 2 ALs, I got 2 ALs. Hey, we're all balanced. Alright. Let's just keep moving on here. Okay. So, look for the largest subscript. It's a 3. Over here it's a 2. That's an odd even problem, and the solution is make the odd one even. That now gives me 2 times 3. That's 6 of those, so I'm going to put a 3 times 2 to get 6 over here. As soon as I do that, I have 3 bariums, so I'm going to come over to here and give myself 3 bariums. Now if I look at the iron, I have 2 irons, and over here I have 1, so I'll have to put a 2 here. Just keep on going, folks. I'm loving this stuff. Alright, largest subscript, 3. Over here it's a 2. When that happens, you know what to do. Make the odd one even. That gives me 6 oxygens, so I'll put a 3 here to get 6 oxygens here. Now I have 2 times 2, that's 4 aluminum, so I'll put a 4 here. Great, let's keep moving on. Largest subscript. Here's my largest subscript. I have 2 silvers, so I'm going to come over here and put a 2. Now that gives me 2 nitrates. So if I have 2 nitrates here, I need to have 2 nitrates over here, so I'm going to put a 2 here. Now that gave me 2 sodiums. I didn't mean to do 2 sodiums, but that's what it gave me. And I come over here, look, I needed 2 sodiums. Done. Ooh, this next one looks very tricky. Let's see here. I've got a 4 for the phosphate, and over here I don't have anything, so I'm going to start off by doing that first. Now look what that gives me. That gives me 4 times 3, that's 12 potassiums. Now what times 2 gives me 12? The answer is 6. Now as soon as I do that, I have 6 times 1, not 4, but look outside the parentheses, 6 sulfates, and over here I only have 2. So what times 2 gives you 6? The answer is 3. In doing that, I gave myself 3 zirconiums, and look, I needed 3 zirconiums. I love how it just all works out. Try the next one. Largest subscript, let's go with the 2 oxygens here, and I've only got 1 over here, so the answer is I'm going to have to multiply this one by 2. As soon as I do that, my oxygens are balanced, but I now have 2 times 2, that's 4 hydrogens, so when I come over here, I see I have 2, so what times 2 is 4? The answer is, why 2, of course. Now, let's see, number 14, my largest subscript. I have some choices here. I have 3 of these. I have 2 of those. I'm going to go with the odd even and try that one first. So I'm going to put a 2 here to make my odd even. In doing that, that gives me 2 times 3, 6 bromines. So I'm going to put a 3 here. Now in doing that, that gives me 3 zincs. So I put a 3 here. Now that gives me 3 carbonates. And look at this. I needed 3 carbonates. I'm done. Next one. Let's see. I've got 3 H's here and I've got 2 H's here. You know what? That's an odd even problem, so I'm going to put a 2 here. In doing so, I give myself 2 times 3, 6 H's. What times 2 equals 6? Well, I think by now we know the answer is 3. Now, in doing this, I give myself 2 N's and I only have 1 here, so I'm going to have to put a 2 here to balance that out. As soon as I do that, you'll notice I have 2 times 3, that's 6 iodines. And here I have 2. What times 2 is 6? Well, 3 times 2 is 6. And let's see now, this next one. My largest subscript, we have a 2 here, and a 2 here, and a 2 here. Doesn't really much matter where I start. I'm going to try balancing this one first. So I got 2 oxygens here. So I've got 1 over here. I'm going to multiply by 2. In doing so, I have 2 times 2, that's 4 lithium, so I'm going to put a 4 here. Now, 4 times 1 is 4 lithiums, but that also gives me 4 Fs. Over here I have 2. What times 2 is 4? Well, the answer, of course, is 2. Alright, I think there's just one more on this side, number 17. Alright, let's see here. I've got 3 Mgs, and over here I only have 1, so I'm going to put a 3 here. Now, in balancing the manganese, since I gave myself 6 nitrates, and over here I only have 1, so I'm going to put a 6 here. Because 6 times 1 is 6. Now, that gives me 6 times 1 potassiums. I have 6 of them. Over here I have 3. What times 3 is 6? 2 times 3 is 6. But in doing that, that gave me 2 phosphates, and look, I needed 2 phosphates. It's great how it just works itself out like that, like magic. Well, welcome to the back side of the helmet. You know what? Let's see if we can get this a little bit straighter. It's kind of bumming me out. Alright, how's that? Okay. So, what we've got now is I've got a 3 here. I've got a 2 here. Odd even problem. You know what to do? Make the odd even. But in doing so, I have 2 P's, so I have to come over here and put a 2. And now I have 2 times 3. I have 6 F's, so I'm going to have to put a 3 over here. Try our next one. Largest subscript. Well, here I'm just going to do this. Let's see how it works. I'm going to do some changing here. So I've got a 3 here and I've got a 1 here. I'll start with that. I'll put a 3 here. But now watch what happens. When I put that 3 here, I come over to the other side. I go, oh, wait, now I got 2 of these. Well, now that gives me an odd even problem, right? Because this one's odd and this one's even. And when you have an odd even problem, you're supposed to make the odd one even by multiplying it by 2. So I'm going to take that, and I'm going to get rid of that. Let's see, I'm going to try to get rid of that. Get rid of that. And what I'm going to do instead is, I'm going to turn that into a 6. Now that gives me 6 F's. What I just do, I just multiplied my 3 by 2 and got 6. That's what you do with odd evens. Now that gives me 6 F's, and over here I have 3. So what times 3 is 6? Well, 2 is. Now that gives me 2 aluminums, and I needed 2 aluminums. And over here I have 3 carbonates, so I'm going to have to put a 3 over here. And putting a 3 there, look what that gave me. They gave me 3 times 2, they gave me 6 ammoniums, and that's what I needed. Just like magic. Now this is going to freak you out. When I made this assignment, I just started throwing down chemical reactions. I wasn't paying any attention to what it was. But watch this. I can't believe that this happened. Alright, let's try this next one here. Largest subscript is a 4. Over here it's a 2. So I go, you know what? I'm just going to multiply this by 2. Then I come over to the other side and I say, well, I've got TIs, a balance. I got S2 over here. Oh, I spoke too soon. Whoops. Okay, I guess that balanced pretty darn easy. I wasn't where I thought I was on the assignment. Okay, you'll see in a minute what I was talking about. Alright, let's try the next one here. That was embarrassing. Okay, let's see. We've got 3 here is my largest subscript. And over here, I don't have it, so I'm going to put a 3 here. Now my sulfates are balanced. But that gave me 3 times 2. That gives me 6 H's. So I'm going to come over here and put a 3. And the reason I'm going to do that is because 3 times 2 is 6. 3 times 2 is 6. Let's see now. I've got 2Al, so I'm going to have to put a 2 here. And we're done. I think now we're getting to the one I was thinking of. Okay, well, let's just try this here. Largest subscript, it's a 3. I have 3 NIs, so I'm going to put a 3 here. In doing so, I gave myself 3 times 2, that's 6 hydroxides, and over here I only have 1, so I'm going to multiply that by 6. Now I have 6 hydroxides, and 3 times 2 is 6 hydroxides. Now this also gives me 6 times 1, 6 Ks, so what times 3 gives me 6? Answer, 2. If I multiply by 2, I now have 6 Ks on that side also. So 2 times 3 equals 6 times 1. Now that gives me 2 times 1, which is what I needed. Here I have 3 nickels, and here I have 3 nickels, even though I wasn't looking for it. Okay, now this is where I was thinking. Now look at how very different these are. These two don't look anything like each other, do they? Nothing like each other. And I just happen to throw them on paper. Watch what happens. Alright, where am I going to start? Mr. Sand says start with your largest subscript. Looks like here I got a 4, and over here I have a 2. So I'm going to start off by multiplying this by 2. As soon as I do that, I have 2 times 2, that's 6 coppers, and over here I only have 1, so I'm going to put a 6. See what's happening here? It's pretty freaky. Now, 6 times 2 is 12 chlorines, and over here I have 4. What times 4 is 12? Why, 3 is. And I'm done. And these two balance identically, and I had no intention of it being that way. It just worked out that way. And by the way, those are pretty freaky subscripts. 6, 1, 2, 3. It's worth noting, too, that if you end up with something, let's just say when you did this, let's look at number 21. What if you got 6, 4, 2, 6? It balances, but it's not as reduced as it could be. So you always want to present it in the lowest possible form. So if you can divide them all by 2 or 3, you need to do that. You need to have it in an unreducible form. Let's try moving this up here. And okay, start with your largest subscript. I have a 4 here, and I have a 3 here. Well, you know what I'm going to do? I'm going to say this. I'm going to take this one here and multiply it by 4 is what I'm going to do. Because if I multiply 4 times 3, that gives me 12. I'm going to come over here and put a 3. Now maybe I'm going the wrong direction, but that just seemed like the thing to do, to swap those 4s and the 3s. Now, that gives me 3 SIs, and over here I only have 1, so I'm going to multiply this by 3. In doing so, I end up with 3 times 2, that's 6 sulfates. Here I have 3, so I'm going to have to put a 2 in front of it. In doing that, I also have 3 times 2, that's 6. 3 times 2 is 6. Now watch this. 2 times 2 is 4. Yep, balances out. Try our next one here, our largest subscript. Let's go with the 2K. So I'm going to put a 2 here, so my K's are balanced. In doing that, I end up with 2 hydroxides. Well, that's what I have over here. Let's see, over here I have 2 K's. Over here, I did that one. Duh. Okay, is that really all I have to do? Is it that easy? Wait a second. Seriously, that's all I had to do. Everything is balanced. Oh my gosh. Yep. 1 lead, 1 lead, 1 carbonate, 2 Ks, 2 Ks, 2 OHs, 2 OHs. Oh my goodness, that was an easy one. Alright, let's try the next one here. I got 4 PO4s, and here I only have 1, so I'm going to multiply by 4. As soon as I do that, I have 4 aluminums, so I need to have 4 aluminums here. I need to multiply by 4, because 1 times 4 is 4. But 4 times 3 is 12 chlorines. What times 4 equals 12? 3 times 4 equals 12. Now when I do that, that gives me 3 carbons, and look, that's what I needed. Just like magic. Well, you know what? We finished up with all the easy ones, and these last 4 are challenge ones. Let's just see how you do with this. Chances are you're watching this video because you got to 27 and said, whoa, what's going on here? What's going on here is this. I see hydroxide over here, but I don't see it over here. Well, what that means is, by the way, this is how hydroxide forms. You throw sodium into water, it makes hydrogen gas and sodium hydroxide. This is what happens. This is how the hydroxide ion forms. So, I can't balance hydroxide versus hydroxide, but I do have sodium, oxygen, hydrogen, sodium, oxygen, hydrogen. So it must be balanceable. So what I'm going to do is I have to add up all the hydrogens on this side and balance it against the hydrogens on this side. So here I have 2. Here I have 2 plus 1. That's 3. That's an odd number. When you have an odd even, the thing to do is make the odd one even. Well, it's this one that's making it odd because this is 2 and this is 1 hydrogen. So I'm going to multiply the odd one by 2. Now I have 2 hydrogens plus 2 hydrogens. That's 4 hydrogens. And here I only have 2. So what times 2 is 4? 2. As soon as I do that, that gave me 2 oxygens. And over here, look, I have 2 oxygens now. I have 2 of these. That gives me 2 oxygens. This also gives me 2 sodiums. And over here I only have 1, so I put a 2 here. So it looked challenging at first, but really it wasn't so bad. Now we get to hydrocarbon combustion. Hydrocarbon combustion is a real challenge for a lot of kids. Now the deal is, remember, when you see carbon followed by hydrogen, it's a hydrocarbon combustion. This is my advice to you. Keep in mind that because oxygen occurs in multiple places in these, it's usually best to balance the oxygen last. So my advice to students is always balance the carbons, balance the hydrogens, and do the oxygens last. So I have 6 carbons here, I have 1 carbon here, I'm going to multiply this by 6. I'm not going to balance the oxygen like I normally would. Instead, I'm going to balance the hydrogen. I have 12 hydrogens here. I have 2 hydrogens here. So I'm going to multiply that by 6. Now I have 6 carbons, 12 hydrogens, 12 hydrogens. Now I'm going to do the oxygens. So here's what I've got. On this side here, I have 6 plus 12. That is, I'm just going to write really small, that is 18. I have 18 oxygens in the products. I need to have 18 in the reactants. Let's see how many I have right now. I have 2 plus 6. Now I would like to not mess this up, because if I change this, I got to change all this, and I don't want to do that. So here's what I'm going to say. 6 plus what equals 18? And the answer is 6 plus 12 equals 18. So I need to multiply this by something that's going to give me 12 oxygens here, and that's going to be a 6. Let's just see if I got it right. 6 times 2 is 12, plus 6 is 18, and that's what I have here. 6, 6, 12, 12. We're done. And let's try the next one, and this one's even trickier. So this next one, again, is a hydrocarbon combustion, so balance the carbons, balance the hydrogens, save the oxygens for last. So I have 8 carbons here, and I'm going to put over here, I'm going to put 8 carbons here. And then I'm not going to do the oxygens, I'm going to do the hydrogens. So what I've got now is I've got 18 hydrogens here, and I've got 2 here. What times 2 is 18? Well, 9 times 2 is 18. Now I'm going to count up all of my oxygens and try to balance them. So what I have here is 8 times 2, that's 16, plus 9, that's 25. I have 25 oxygens on this side, and over here I have 2. Uh-oh, that's an odd-even problem. 2 and 25. Now when you have an odd-even problem, what do? You take the thing that's making it odd, that's giving me 9 oxygens, and you multiply it by 2. So what I'm just going to cancel this out, and I'm going to multiply it by 2, and that's going to give me 18. Well, now I have 18 times 2, that's 36 hydrogens. So what times 18 gives me 36? Well, 2 does. But as soon as I do that, I have 2 times 8, that's 16 carbons. Over here I have 8, so I'm going to get rid of the 8, and I'm going to replace it with 16. Now I'm going to add up all my oxygens. Well, now what you're going to find is, on this side here, you have 16 times 2, that's 32, plus 18, that's 50. So now what I have over here instead is 50. I doubled it. And that is balanceable, because what times 2 is 50? And the answer is 25. Admit it, that one was pretty tricky, but doable. Alright, and now my last one. It's a lot easier than it looks. Again, this is a case of where I don't have hydroxide here, but I do have it here. That's how it forms. So I had to balance my hydrogens and oxygens separately. So let's just try this. Let's start with the hydrogens. I've got 2 hydrogens here plus 1 here, that's 4. I only have 2 here, so I multiply by 2. Now in doing that, that gives me 2 times 1, that's 2. 2 times 1 is 2 oxygens here. I have 1 calcium, I have 1 calcium, I have 4 hydrogens, and I need to have 4 hydrogens. I have 2 here plus 2. Hey, I am done. I'm done with this one. I'm done with the whole homework. I don't know about you. I think this stuff is fun.